In this video, we are going to review all the types of equations that we've learned so far, and this will help prepare you for the quiz. The first one, we have b minus 4 all divided by 3 is equal to 7. So notice where our variable is. We want to get this b by itself. Since that's in the numerator, we can't do anything with the b minus 4 until we have undone that division by 3. So to do that, we will multiply by 3 on both sides. So you could write this as times 3 on the left and times 3 on the right. If you don't normally draw the parentheses, you could also just put a little dot to represent times 3 and a little dot to represent times 3 there. Either way, it doesn't matter. What's important is that we have multiplication by 3 and division by 3, which is equal to 1. And the remaining equation would be b minus 4 equals 21. Finally, to get b by itself, we'll do the inverse of subtracting 4, which is adding 4. So minus 4 and plus 4 cancels out, and we're left with b equals 21 plus 4 is 25. In number 2, we have 5 equals 8p minus 2 minus 7p. We don't have any parentheses, so the next step is going to be combining like terms on the left and combining like terms on the right. So on the left side of the equation, we just have a 5. We can't do anything with that. There aren't any terms to combine. On the right, we have 8p and negative 7p. So 8p minus 7p are like terms. And we can simplify that to be 1p, or just p. Then everything else is going to come straight down. We want to isolate the p, which means we need to move this negative 2. The inverse of minus 2 is plus 2, so we'll add 2 on both sides. Finally, we simplify. 5 plus 2 is 7. Bring down the equal, bring down the p. Negative 2 plus 2 cancels out. And our solution is that p equals 7, or 7 equals p. Number 3. Again, we don't have any parentheses, so we're going to move on to combine like terms. On the left, we have negative 8y and positive 6y are like terms. So we can combine them. Negative 8 plus 6 is negative 2. And we'll bring down the plus 4, the equal sign, and the 20. To isolate this y, first we need to move the positive 4. Then we can split the negative 2 away from the y. So first, we'll do the inverse of adding 4. Bring down the negative 2y and the equal sign. 20 minus 4 is 16. Now we can split the 2 away from the y. Since that means negative 2 times y equals 16, we're going to do the inverse of multiplication, which is division. Negative 2 divided by negative 2 is 1, so y equals 16 divided by negative 2 is negative 8. Number 4, Now we do have a set of parentheses. Since we're trying to isolate the variable y, we can distribute the 3 to each term in that set of parentheses, and that helps us eliminate the parentheses. Remember, distribution means multiplication, so 3 times y plus 3 times 4 equals 18. Now we need to move the constant term to the right. The opposite of plus 12 is minus 12. Bring down the 3y and the equal sign and simplify. 18 minus 12 is 6. Now we can split the 3 away from the y using the inverse of multiplication, which is division. 3 divided by 3 is 1, so 1y, or just y, equals 6 divided by 3 is 2. In number 5, we don't have any parentheses, so we want to see if we can combine like terms on the left and then combine like terms on the right. On the left, we just have negative 11. There's nothing to combine. On the right, 4x and minus 3 are not like terms, so we can't combine them. Moving on to the next step in our solving equations, we would need to move the constant terms to one side. Since we don't have any other x's, we can jump straight to moving the constant terms. So first, we would want to move the minus 3, then we will split the 4 away from the x. So we'll do the inverse of subtracting 3, which is adding 3 to both sides. Negative 11 plus 3 is negative 8. Bring down the equal sign. Bring down the 4x. Now we can split the 4 away from the x using the inverse of multiplication. So divide by 4 on both sides. 4 divided by 4 is 1, and we simplify. Negative 8 divided by 4 is negative 2. So negative 2 is x. Number 6 is one that can be a little bit tricky. If you're looking at number 6 and number 1, notice how they both have division, but there are a different set of steps that we're going to go through to solve this one compared to number 1. So notice that x is in the top of this fraction. Then we have plus 7 as a separate term. Since this is a separate term from the x term, we can go ahead and move that away from that side of the equation. So we're going to do the inverse of addition, which is subtraction, and subtract that 7 on both sides. Negative 3 minus 7 is negative 10. Bring down the equal, and we have x over 2. Finally, we can get x by itself now by doing the inverse of division by 2, which would be multiplication times 2 on both sides. So division by 2 and multiplication by 2, they cancel each other out. And we have negative 10 times 2, or 2 times negative 10, which is negative 20, equals x. So notice how this one was different from number 1. In number 1, since the b was all part of the b minus 4 over 3, this was all one big fraction, we went ahead and multiplied by 3 on both sides first. Over here, this was not one big fraction. We had a fraction plus another term. So in this case, we could go ahead and subtract 7. Number 7 is a little bit longer, but it's the same process for multi-step equation. We're going to distribute, we're going to combine like terms, we're going to move the variable to the left, constants to the right, and isolate that x. So first, let's go ahead and distribute since we have two sets of parentheses. So we're going to multiply 4 times x and 4 times negative 2. And notice that I'm going to multiply negative 3 times 2 and negative 3 times negative 2x. Over on the left side here, we have 11x and negative 11. They aren't like terms. We can't combine them, can't do anything with them yet, so they're just going to come straight down for now. So let's distribute and see what we get. 4 times x is 4x. 4 times negative 2 is negative 8. Now, negative 3 times 2 is negative 6. Negative 3 times negative 2x, so negative times a negative is a positive, 6x. Don't forget about this x here. Now we can work on combining like terms. We have a few things we can do here. Over on the left, since 11, they both have an 11, but they don't both have an x, so we can't combine anything over there. We're going to leave it the way it is, bring it straight down. But on the right, we have negative 8 and minus 6. Those are like terms because they're just constants, plain old numbers. And we have 4x and we have positive 6x. So let's combine those like terms. The x's, 4 plus 6, becomes 10x. And the constants negative 8 minus 6, be careful here, this is a bigger negative number. Negative 8 minus 6 is negative 14. Now we're getting closer. It's not looking so messy. We want to move our x's to the same side. So we have an x term here and here. I would subtract 10x from both sides. You could do it the other way, but notice what happens when I subtract 10x on both sides. 11 minus 10 is 1x, or just x, which is positive. And we like to have positive numbers when we can. And bring down the negative 14. Finally, we want to continue getting x by itself, so we need to move this negative 11 away by doing the inverse of minus 11, which is plus 11. So x equals negative 14 plus 11 is negative 3. Number 8, 9, and 10 are literal equations. You're not solving to get a single number, you're just rearranging this equation so that you have a certain letter by itself. That certain letter is told to us. For number 8, we want to solve for p. That means get p by itself. So notice where the p is. It is attached to the r through multiplication. So before we can move the r, we have to move the s. So I'll say that again. Before we can split the p from the r, we have to move the s. So to move the s, we need to do the inverse of add s, which is subtract on both sides. So on the left, notice we can't actually do m minus s. They aren't actual values that we know. So we can just write it out as m minus s. Bring down the equal sign, and we still have p times r. Finally, we can split these two apart. Since that's multiplication, we're going to do the inverse of that, which is division. So since we want to get p by itself, we're not going to divide by p, we want to get rid of this r. We want that to go away. So we are going to divide by r on both sides. So remember, r divided by r is 1. Then on the left, again, since these aren't actual numbers and we can't simplify that, this is as far as we can go. M minus s all divided by r equals p. For number 9, notice that we have a set of parentheses here, and we want to get w by itself. The most efficient approach to this, in order to get rid of these parentheses, we need to get rid of this multiplication by 13. So to do that, we can divide by 13 on both sides. So 13 divided by 13 is 1, and we're left with w minus 3 equals b over 13. Finally, if we're trying to get w by itself, we need to move this 3 to the other side. To move that 3, we have to add it to both sides. It'll cancel over here, so we have w equals notice that we can't combine b over 13 and the plus 3. They will just stay separate. So w equals b over 13 plus 3. And finally, number 10. We want to solve for a. So that means we want to get a by itself. So if we want a, we need to get rid of this 5. To get rid of this 5, we need to do the inverse of multiplication, which is division. So 5 divided by 5 is 1, and we get a equals 3b divided by 5. We can't simplify anything else because 3 over 5 is already in its simplest form, so we're done.